So, let's go. Number 1. The machine we built to break physics. Every other thing on this list is out there, waiting, indifferent. This one, we built, on purpose. And we switched it on. Deep under the border of Switzerland, there is a ring 17 miles around, colder than deep space, where humans take 2 protons and throw them at each other at almost the speed of light. 13 trillion electron volts of energy squeezed into a point smaller than an atom. And back in 2008, before they turned it on, a very serious fear went around. What if that much energy in that small A space makes a black hole? A tiny one. One that doesn't evaporate. One that just starts to fall inward and eat and grow right here at the bottom of a tunnel on a Tuesday. There was a second fear, and it was worse. A thing called a strange lay. A little knot of a strange kind of matter that, if it touched normal matter, might convert it. Turn it strange, too. And that new strange matter would touch more matter, and so on, until the planet under your feet is quietly rewritten into something that isn't a planet anymore. Here's why you're still here. A black hole that small doesn't grow. It flashes out of existence almost before it exists. And the strangelet? The universe already ran this test. Cosmic rays have been slamming into the moon, into dead stars, into everything, at energies far beyond anything we can make, for billions of years. And the moon is still the moon. The machine was never the danger, but for a few months nobody could prove that. And they turned it on anyway. Number 2, the bullet made of nothing. Forget the black holes made from dying stars. There might be another kind. Older, made in the first fraction of a second of the universe, when everything was so dense that reality could pinch off little knots of gravity all on its own. Primordial black holes. And the ones physicists can't rule out are small. Not small like a star. Small like an asteroid, crushed down until its edge is narrower than an atom. You could be looking straight at where one is and see nothing. No glow, no shadow, just a knot of gravity, the mass of a mountain range, drifting through the dark, invisible. Some scientists think these things might be the dark matter, the missing stuff that outweighs every star in the sky. Which means space could be full of them. And in 2024, a team did the math on what happens if one drifts through our solar system. The answer is unsettling in a very specific way. It would tug on the planets as it passed, nudge our orbits just slightly. But the nudge would be smaller than the error in our best measurements. We would need instruments 10 times sharper than the ones we have just to notice. So one could pass through the neighborhood right now, this year, and we would not feel it, and we would not see it. And the only sign would be a wobble too faint to read. It wouldn't eat you. It would just move the ground under everything and leave. Number 3. The kilonova next door. Take 2 neutron stars. Each one is a dead sun crushed into a city-sized ball so heavy a spoonful outweighs a mountain. Now set them circling each other, closer, faster, until they touch. When they merge, they don't just explode. They forge gold, real gold, and platinum, flung out into space in a shell of glowing debris. And they fire off a scream of gamma rays, X-rays, and cosmic particles in every direction. We watched it happen once, 2017. A wobble in space-time reached our detectors, and then the light arrived from 2 neutron stars that had merged 130 million light-years away. Far enough that all it did was win someone a Nobel Prize. Now bring it closer. Physicists actually mapped the kill zone. The X-rays could scald us from about 3 light-years out. The gamma rays, coming in from the side, reach 4 times that. The cosmic particles up to 40 light-years. And if one of those beams is pointed straight down our throat, the deadly range stretches to 650 light-years, close enough to strip the ozone off the sky and let the sun cook the bottom of the food chain. And here's the part that should feel like a hand on your shoulder. In our corner of the galaxy, a merger that close happens less often than the entire universe has existed. The gun is real, The barrel is astronomically long. You start to see a pattern here. Terrifying mechanism, impossible odds, hold on to that. It's about to bend. Number 4. The gun that's already aimed. 8,000 light years away in the direction of Sagittarius, there is a star that had a nickname for 20 years. The Death Star. Its real name is WR-104, and it's a monster in its final act wrapped in a spiral of glowing dust that turns like a pinwheel. Beautiful. And when astronomers first measured that pinwheel, they realized they were looking at it almost perfectly face on, which meant the star's spin axis, the direction it would fire a gamma ray burst when it dies, might be pointed within 16 degrees of Earth. 16 degrees. Close enough that people who study this for a living use the word gun. A loaded one, 8,000 years of light away, aimed more or less at your face. For 2 decades, that's where it sat. And then, in 2025, a new team pointed some of the sharpest telescopes on Earth at it and measured the orbit again, and the angle moved. The system is tilted 30, maybe 40 degrees away from us. The burst, if it comes, sails off into empty space and misses. Probably. That word is doing a lot of work and the scientists know it. But sit with what just happened. For 20 years, the smartest people in the field looked at a real star and genuinely feared it. Then they measured better, and the fear got smaller. The threat didn't change. Our knowledge did. Remember that. Number 5, the sun's other setting. Everything so far has been far away. Now look up at the thing that keeps you alive. 8 light minutes away. The sun. You think you know it, you've seen it every day of your life, but you have only ever seen it in one mood. In 2024, a team went through more than 50,000 stars just like our sun, watched by the Kepler telescope, and they were hunting for superflares. Not a normal flare, a superflare, an eruption that releases more energy than 1 trillion hydrogen bombs going off at once. And they found that stars like ours do this roughly once a century, 10 to 100 times more often than anyone thought. Once a century. On stars that are, in every way we can measure, the same as the one outside your window, we have never caught our sun doing it. But the statistics say it can. And a flare like that would make the Great Storm of 1859, the one that set telegraph wires on fire, look like a warm afternoon. It probably wouldn't kill you where you stand. The air would hold. But the satellites would die. The power grids would burn out from the inside. The transformers that take years to replace would cook in an afternoon. And the aurora would come down out of the poles and light up the sky over the desert, green and silent and wrong. Number 6. The sky catches fire. This one didn't come from space, it came from a chalkboard, and it is the darkest bet ever placed. Before the first nuclear weapon was tested, one of the physicists ran a calculation and came back pale. The bomb would make a fireball hotter than the core of the sun, and he wondered out loud whether that heat might light the air itself on fire. Not metaphorically. Whether the nitrogen in the atmosphere could start fusing in a chain reaction that would race outward through the sky and around the whole planet and not stop until every last breath of air had burned. So they did the math. A report went around that said, in careful language, that a self-sustaining fire in the atmosphere was not likely to start. Not likely. But here's the thing. Nobody says loudly enough. The numbers they needed to be sure, the exact odds of those reactions, didn't exist yet. Nobody had measured them. One of them reportedly told the project director that if there were any real chance of burning the sky, all work should stop. Another took bets on it the morning of the test. And then, 81 years ago, on this exact date, they walked to the bunker and they pushed the button anyway. This is the moment this whole list turns. Because up to now, every fear had a comforting answer waiting at the end. Here, the comforting answer was a calculation with a hole in it, and they lit the fuse regardless. That's what a black swan actually is. Not the monster you can see, the math you can't finish, and the button you press anyway. Number 7. The particle that eats protons. Everything that has ever hurt you did it with force. A crash, a fall, a fire. This one doesn't need force. It just needs to walk past you. Physics predicts something called a magnetic monopole, A particle with only one magnetic pole, north without south, a thing so lonely, no one has ever confirmed we've seen it. And there is a rule about what happens when a monopole meets a proton, the little brick that every atom in your body is built from. The monopole can make the proton fall apart, not break it, catalyze it. The way a spark catalyzes a fire without becoming the fire. And the monopole doesn't get used up, it keeps going. One of these things could drift through a planet and leave a wake of protons quietly deciding to stop existing, matter unspooling into light and lighter ghosts, and the monopole sails out the other side unchanged, ready to do it again to the next world. We have never caught one. Once, on Valentine's Day in 1982, a single detector twitched exactly the way a passing monopole should make it twitch. One clean event. It never happened again. So either it was a glitch or something impossible walked through a lab in California one night and kept walking, and we've been waiting 40 years for it to come back. Number 8. The whip across space. When the universe was newborn and cooling, it may have cracked, the way a lake cracks when it freezes, and those cracks might still be out there. Cosmic strings. Not string like thread. String like a flaw in the fabric of space itself, thinner than a single proton, stretched across the sky, holding the mass of a mountain range inside every atom's width of its length. A thing like that is under unbelievable tension, and it whips through space at almost the speed of light. If one passed between you and a distant galaxy, you'd see the galaxy twice, side by side, split by a line that isn't there. Two images of one thing and nothing in the gap. That's how you'd know. That's the only way you'd know. Nobody has ever proven a cosmic string exists. They live in the equations, in the leftover hum of gravitational waves that detectors picked up a few years ago, where a handful of physicists point and say that could be them. A crack from the beginning of time, still traveling, still under tension, carrying a razor of pure geometry through the dark. Probably not real. We are not sure. And that uncertainty is the whole reason it's on this list. Number 9. The cascade above your head. After the black holes and the monopoles and the cracks in space-time, here is the one that's the most likely to actually happen, and it's made of our own garbage. Back in 1978, a NASA scientist described a nightmare. Put enough junk in orbit, and one collision throws off a cloud of fragments. Those fragments hit other satellites, which throw off more fragments, which hit more satellites. A chain reaction, feeding itself faster than the thin air up there, can drag any of it back down. Once it starts, it doesn't need us anymore. It just runs. And right now, above your head, there are around 40,000 objects big enough to track, and more than 1 million fragments too small to see, each one moving at 10 kilometers a second. That's faster than a rifle bullet 10 times over. A fleck of paint at that speed cracks a window on a spacecraft. In August of 2024, a single rocket stage broke apart and made 700 new pieces of shrapnel in an afternoon. The near-miss warnings in the busiest orbits have jumped to several times what they were 10 years ago. If it tips over into a full cascade, you don't get an explosion, you get a slow closing of the door. No more weather satellites, no more GPS, no more launches through a shell of screaming metal. We would lose space not with a bang, but by burying ourselves under everything we already left up there. Number 10. The one nobody modeled. Here's the trick I've been playing on you. Every single thing on this list we can name, the collider, the invisible black hole, the dead stars colliding, the star that was aimed at us, the sun's hidden mood, the burning sky, the particle that eats matter, the crack in space, our own orbiting junk. We can name them because someone, somewhere, was smart enough and scared enough to imagine them first. But a real black swan isn't the monster on the list. It's the empty space at the bottom. The one nobody has thought of yet. Because the whole point of these events is that you can only fear the ones you can already picture. Every single item you just heard was once an unknown, right up until the moment a physicist sat down and dreamed it into a threat. Before that, it was nothing. It wasn't even a fear, it was just the future, arriving. So the thing that actually gets us, if anything ever does, probably isn't up there on the list you just watched. It's the one no one has written down. The one that will look completely obvious the day after and completely invisible every single day before. And there is no telescope for that. There is no calculation. There's just the quiet fact that the scariest number in all of physics is the one we haven't figured out we should be afraid of yet. You can only ever brace for the swans you can see. The one that matters is the one you can't.